Welcome to this session on crude to chemicals, the future of refineries. Well, I come from Ministry of Petroleum and Natural Gas. I've been working before that in Indian Oil Corporation R&D and worked in refinery also. So we are passing through a energy transition phase, and you are hearing like a lot of buzzwords like green hydrogen, biofuels, decarbonization, net zero, so many things are coming up. Uh, as far as refineries are concerned, I can just mention here that be sure that refineries are going to stay, and the crude oil production as well as the processing is going to increase. Uh, the latest estimate, what we have made at the ministry, indicates that by 2030, we will be touching about 320 million metric tons, which is currently at 250. By 2040, we are likely to touch 400. So there may be some dynamics which may change this figure, but at present, this is the scenario. Uh, Crude to oil chemicals basically is what is picking up nowadays, and there is likely like overall energy scenario will be increasing, the demand will be increasing, but with time the gasoline production and diesel production may go down, but in the scenario of overall energy it will be increasing. So however, there is a push towards petrochemicals also, and a lot of companies are now shifting gears, and they are making more of petrochemicals from crude. So like the new refinery of HPCL which is coming up is having 26% of petroleum intensity index. The current petroleum intensity index of our refineries is about 7%, and which is likely to increase to 11%. That's the average by 2030. There are several processes which are being talked about. COTC is one, crude to chemicals, directly. Then there are processes like high severity FCC. Acid gasification is also one, and hydrocracking is also increasing in the refineries. To start the session, I think we have only two speakers are here, and two are likely to join. One has joined from the web, and one is likely to join us soon because he's coming from Bangalore, and the flight is delayed. So what I will do, I will just give for this all the speakers some time for initial remarks, and I will start with Shri Partha Mehta to give his initial remarks through presentation.
Yeah, I thought a picture is worth 1,000 words, and hence I'm making a presentation instead of just remarks. So the first thing is, this panel discussion is on oil to chemical future of refineries. Future of refineries. Actually, the future of refineries is COTC, or crude oil to chemicals. But I'll explain that to you as we go along. The second is a disclaimer. Basically, don't believe what I say, but do your due diligence and then believe. I would suggest you can even stop your due diligence. So the next, the presentation basically runs into two parts. One is the drivers, why we are going towards COTC, and that will cover decarbonization, sustainability, and integration. Integration means refinery and petrochemical integration. And finally, a few words on the brave new world of refining, which is COTC. And I'll touch upon feed, process, product, and technology. This can be considered as a mission statement for COTC. We are doing all this because of global warming, and I think you have heard enough yesterday and today that the planet is heating up. We are putting roughly 40 gigatons of CO2 in the atmosphere every year. And within the next 5 years, which is too close for comfort, we will cross the red line of 1.5 degrees centigrade global warming. Fossil fuels being hydrocarbon, they contribute to global warming, and hence we have to do something about fossil fuels. And now there is already, the good news is not true in India, but globally, the mobility transition has taken off from ICE, which is internal combustion engine, to electric vehicles. As a result, in fact, globally in 2023, we are approaching 15% EVs. In India, it is very, very low at 2%. But basically, the world and the three major sectors, which is China, US, and EU, European Union, the EVs are really taking off. It's going to happen in India as well, believe me. Now, so we have, with that, there will be a demand peak for the refined products. There will be a peak in gasoline, and there will be a peak in diesel. Of course, the peak in India will be delayed by some time. Now, in order to reduce emissions, the first step in reducing emission is what is called net zero. That is, do not put any emissions into the atmosphere, which means no scope 1 emissions, no scope 2 emissions, and no scope 3 emissions. The majority of the pledges by OECD, the big emitters in the past, and oil majors, oil refining and chemical majors, is 2050. China net zero is 2060, India's net zero is 2070. So we have a small lag with the rest of the world. Now, what is COTC? Refining for the last 100 plus years is a manufacturing plant to produce fuels primarily, and chemicals is just an afterthought. COTC means refining will just produce chemicals and fuels will become an afterthought. And the reason this is important is because we want to sequester the carbon in the fossil fuel in the chemicals via COTC. So let's talk about the next 3 decades and get you a picture of 2050. Now, a lot of us won't be around, but for the net zero to happen in 2050, the fossil energy has to decline from 83% today to 23% in 2050. Oil, which is today 31%, has to decline to 8%. Renewable energy, somebody has to provide that energy. That will be taken up by renewable energy, which today is 9.5%, will go up to 54%. The primary is solar and wind, with a little bit more from hydro. The low carbon hydrogen, there was a big session on green hydrogen yesterday, will account for 12% of the energy. So renewable power is the superstar, and the next supporting actor is low carbon hydrogen. And the extras in this new world will be bio and circular, which is 4% only. If you translate that oil of 8%, the crude refined in refineries will come down from roughly 100 million barrels. We are today around 2023, 101 million barrels. This is global. It will come down to 26 million barrels. Chemical demands will rise even after circularity, and so there will be an 18 million barrels of oil to meet the 2050 demand will be around 18 million. So COTC means 69% oil becoming chemicals. Now, we always produced chemicals in the past. There are roughly 600 refineries in the world, and the total average oil to chemical is 10%. The first generation of high integration is 15 to 30%. So Barmer, which is in 26%, will be a first generation, will not be COTC, but first generation integration. There are roughly around 5 new refineries in China which are producing between 40 to 55%. And a true COTC, which is above 65%, is non-existent today. It's the ultimate in integration in refining and petrochemicals. Refining switches from fuels to chemicals. Fuels become a niche product. Essentially, only the fittest of the refineries will survive, and it will be a sunset for standalone crackers, because crude will be converted to petrochemicals. Okay, so now, having known that our destination is COTC, what happens in COTC? So the feed will be crude oil. It will continue to be C2 LPG from natural gas liquids, and you will also have LNG. Remember, natural gas remained at about 12% within the fossil fuel in 2050. There will be renewable biomass, plastic waste, and also recycled carbon via COTC. The biomass will include non-edible feed, agricultural waste, forestry waste, sludge, and municipal solid waste. And in future, we will grow algae. Because why algae? Because it has the highest uptake of CO2 from atmosphere. It beats trees, it beats crops. And of course, there will be plastic recycling, which is in a completely nascent stage. It will grow to become a major recycler of carbon in the world. And the plastic recycling will include pyrolysis, depolymerization, and solvent treating. Solvent treating is the best of plastic recycling because the carbon intensity versus virgin plastic is reduced by 90%. Pyrolysis reduces by roughly 50%. So it will be a hybrid feed with carbon coming from a variety of sources. Let's talk about process. Now, COTC, essentially, that is the future of refineries, you will still split the crude oil into three: light ends, mid-cut, which is VGO or vacuum gas oil, and heavies, which is VR. The heavies cannot be cracked to chemicals, and hence it has to be upgraded to mid-cut or light ends. And for that, we can either have resid hydrocracking, slurry, or ebullited using what is called low carbon hydrogen. The mid-cut is essentially can be catalytically cracked to chemicals and light ends, and for that we will go towards new technology, which is the ultimate severity FCC. Today's FCC, you can get ethylene and propylene around, high will be around 22%. The plan is to go up to around 30% from an FCC, and produce light ends to go to a steam cracker to increase olefins to around 50%, and along with aromatics of around 20-25%, crude to chemical COTC will be above 70%. Light ends would be steam cracked, but again, the steam cracking has to be based on molecular management. Basically, only those which give us high yields will go as a feed to steam cracking. For example, C3 will not go to steam cracking, though it goes today, because steam cracking is extremely energy intensive and emission intensive, and it cannot be sustainable in 2050. So C3 has to be dehydrogenated to PP. The heavy naphtha will be cat reformed to aromatics, and the remainder, which is diesel material, will be this is in 2050, so don't get alarmed today, would be hydrocracked to light ends. You will get a bunch of C1 as a surplus from all this cracking, that is methane. And so we have to have an SMR or ATR, which is steam methane reforming or autothermal reforming to syngas. And the syngas can then produce syngas chemicals or blue hydrogen. And the hydrogen will become, for refinery, COTC, will be the fuel for decarbonization. So COTC essentially converts crude oil similar to today's refining configuration to olefins and aromatics. The next is product. Now chemical is a broad term. So what are the products we are talking about? So essentially, we don't want any single-use polymer. We want durable or long-lasting polymers. And we have to evolve from metals to engineering and performance polymers. Why? Because polymer still has low emissions compared to the metals. We will evolve by 2050 when we have the full COTC. The COTC will produce new materials like FRP, fiber reinforced plastic, along with carbon fiber, membranes and electrode material, solar PV materials, battery, electrolyzer, and other fuel cell materials, and also carbon nanotubes and graphite as the new material of the future. Now, those refineries which produce elastomers, lubricants, and solvents can still continue. Only fuels will be negated by 2050. So essentially, COTC, instead of being a fuel producer, will be the new material producer of tomorrow. Technology. Now, there will be a lot of technology development, and in fact, IEA claims that roughly 50% of the sustainable technology required for 2050 is still not being developed. So there's a bunch of new technologies. And the basic thing which changes is up till now, 100, 150 years, engineering always used fossil fuel as a primary energy. Tomorrow, they have to consider renewable power as the primary energy. And that will change engineering completely. Chemical engineering, electrical engineering, all engineering. So how will the plants change? The COTC of 2050. Now, essentially, chemical engineering or hydrocarbon processing consists of heating, reaction, and separation. So all of them, there will be maximum electrification. So if you have R&D people in the room, you have to think electrification of products of heating, reaction, and separation. So we will employ in big plants heat pump and vapor compression. There will be resistive, inductive, and microwave heating, as well as plasma heating via lasers. We will minimize steam boilers and fired heaters. They are products of yesterday. A reaction, this is unfortunate, only caustic chlorine today amongst the major chemicals, used electrochemistry. Tomorrow, a lot of products will start using electrochemistry. There will be a big boom in electrocatalysis, photocatalysis, and laser synthesis. Now, I was saying, I'll give you an example of steam cracker, which is, people keep on talking, let's build one steam cracker every 2 years. Steam cracker will become obsolete by 2050. So please stop and think before you build one steam cracker every 2-3 years. The wave of the future is what is called RDR, Rotary Dynamic Reactor, wherein the input to a steam cracker is not fuel, but power in order to produce olefins, ethylene, and propylene. Existing steam crackers will remain, but they all have to become more sustainable in the future. Separation. Whenever we think of separation, we think of distillation. Tomorrow, distillation will start getting replaced by rotary and divided wall columns, which is still distillation, but by centrifugal separations and diffusion across the membranes. In other words, it is a golden opportunity for innovation, for young people. Don't commit the same mistakes of the past, but innovate for this brave new world of COTC, which is the future of refineries. Thank you.
Thank you, Dr. Matra, for comprehensive coverage and covering all the facets of COTC. Now I will shift to Dr. Chiranjeevi from BPCL. Dr. Chiranjeevi, I will just start with a question only. BPCL doesn't have a cracker, I think. So how are you approaching COTC? Like, what are the approaches you are having for COTC?
First of all, very good afternoon, everybody. And I would like to thank Pravinji, who is responsible for my presence over here and for his perseverance, and also I feel it is an opportunity. I'm enjoying all these sessions since yesterday. And the crude to chemicals, this is a very important topic as far as refining concern. And as first thing is that Dr. Partha Mitra, he made our job is much more easy by covering all aspects of this crude to chemicals. Now I will come to the question of Dr. Alokji. And you are right that we don't have separate this one, but this crude to chemical concept, if you see, and although Dr. Maitra is already told, all refineries typically we are making chemicals. It is nothing new. If you look at worldwide or within our India, or I am being from Bharat Petroleum Corporation, if you look at that, we had been producing chemicals, but it is in the typically a range of 8 to 10%. But of late, we also changed our direction. Now, in Kochi refinery, we started making more chemicals by putting secondary units like high severity FCC. So we are going up to 20% of chemicals when compared to this normal average of 8 to 10%. So, and also we can see that why these refineries, those are forced to think about this crude to chemicals. I would like to give small perspective that because refineries sustainability in the long run is a question mark, and we need to also have more profitable in the operation as well. We need to meet environmental mandates also, and by keeping these aspects, refinery as Bharat Petroleum Corporation, we continuously striving to meet and also improve the GRMs of our refineries. And at the same time, as a Bharat Petroleum Corporation, we have mandated ourselves that we need to be net zero by 2040. So that that is the commitment which we have mandated for ourselves in the in line with our Honorable Prime Minister's net zero goal of 2070. So part of this, first thing is that how to improve the refinery margins. Because as you all know that the demand for petrochemicals is peaking by 2030. Means after that, the growth for the transportation fuels, mainly the refineries currently in India, the approach, operational philosophy is more fuels, less chemicals. But now the new approach is that can we increase that more chemicals and less fuels because of the challenges which we have discussed so far. So now as a BPCL, we started in the Kochi refinery an investment of with the investment plan of 20,000 crores. Part of this, we started integrating petrochemical complex. Likewise, we recently started and also we got government approvals or other necessary things that we are going ahead with 45,000 crores investment in Bina refinery towards this petrochemical complex. So I hope, Dr. Alok, I answered.
Thank you. Thank you very much. Now I will shift to Mr. Partha Sur from Haldia Petrochemicals. Mr. Partha, are you able to hear us?
Yes, yes.
My question is, there is a saying that mixed feed cracker is the choice of future. So how do you see this statement?
Very good afternoon to my dignitaries on the dais, Mr. Sharma, the moderator, Dr. Moitra, and Mr. Thota. See, it is also an opportunity to share the perspective which largely explained by Dr. Maitra, who has made our session practically very simplified. So there is not much of the scope left, but still I'll try to give my perspective here. See, the cracker design can take any form. Okay, when I say it can take any form, it can be the single feed gas or liquid or dual feed like liquid and gas, or mixed feed gas, liquid, light, heavy. So all these combinations are possible, but the context is how do you really think and what kind of feed flexibility in the longer term available in front of you so that you can really plan it that way? So for Asia, particularly the Southeast Asia region like India, Korea, Japan, and Thailand, the perspectives will be different than rest of the other region like, the Middle East and North America and the Kazakhstan. So the latter will have the flexibility to choose like, lighter feedstock like ethane, which will be very, very, damn cheap, and will have the limited flexibility in terms of their product profile. But whereas in this region, if we really think of, the liquid and gas together, maybe naphtha and the LPG, so which gives you, and even the NGL, so a mix of heavy light and gas like LPG give you the larger flexibility, and you can create a larger footprint of larger, the wider product basket. So which will basically determine, help you to set forth the different kind of value chain which you can think of. So starting from what Dr. Moitra has stated, you can go into the different directions, like you maximize your elastomers, fiber, and the synthetics group beside the normal olefins. So merely remaining in the usual range of polyolefins is in the commodities will be very difficult to sustain, and more so for standalone cracker, which will be, if at all come in future, which definitely I think this should come in numbers in India going forwards. They should think of mixed cracker without, if it is not integrated with the refinery. But for the repurposing of any existing refineries, what I think is that it would be a choice of all the streams available in the refineries, and blending it with the other forms of feedstock will give the optimum configuration. That will be tending towards that you are trying to repurpose the refinery and building a feed slate, linking towards more, towards more of chemicals, de-risking your asset and trying to create value in the long run and remain profitable. That would be, so there is no one single answer suits everybody. So it has to be, my opinion, that it has to be designed the long-term perspective the company is aiming at and the product slate it is tied to. So that would be my crisp and possibly perspective answer in this particular question.
Thank you, Mr. Parthasu. Thank you very much. I will now shift to Dr. Partha Mehta. Sir, actually, this India imports about 85% of the crude oil, as we know, and India does not have any feedstock advantage. So how do you see that India vis-a-vis Middle East and other countries who have access to cheap feedstock? So, and already Saudi Aramco and others, they are going in a big way for producing petrochemicals, and they are likely to dump petrochemicals to India. So how do you see this scenario building up?
Actually, the same question was asked to us when we thought of building the Jamnagar refinery. India doesn't have any feedstock. It doesn't have any crude. How come you're building a refinery to make fuel products? Jamnagar has shown that we can get crude from the Middle East or anywhere in the world and still be globally competitive in fuels. And if we can be globally competitive in fuels, we can be globally competitive in petrochemicals.
Thank you very much. I will now have a questions for Dr. Chiranjeevi. Dr. Chiranjeevi, how do you see China has, they have gone for coal gasification. Do you see coal gasification also coming up in India in a big way? Because we have a lot of coal in India. So how do you see this coal gasification?
You see, I see that there is a great opportunity because we have got a tremendous coal reserves within India. But the thing is that we did not develop proper infra to convert that into syngas and syngas to the chemicals so far. So, in this particular aspect, I think that maybe we need more government push or maybe policy push may be required to make it happen. But if you see that as on today, it is not encouraging scenario. But yes, provided that if the government gives push, there may be possibility the way China is doing it in this area.
Yeah, thank you. Mr. Partha Sur, I have a question for you. This crude to chemical value chain is pretty long and capital intensive, and it needs to be optimized. What is your thought process on value chain optimization and at the same time maximizing profitability?
Yeah, here I would like to, once again, Dr. Maitra has really spelled it out in a much better way. So I'll try to add my perspective here. See, the idea is the crude to chemical basically starts with the crude. So if for any kind of new configuration, when we are really thinking about it, so it ought to be, the ultimately the fundamentals of the crude to chemical is the way the fundamental will be changing, the flow sheet of the entire process of refining is changing. So it is simplifying. So that these two aspects have to be kept in mind. And when we do that, this one most important thing is that what kind of crude that we are really thinking in designing it. So if we go starting from the light or extra light, medium, heavy and extra heavy. So last two parts like heavy and extra heavy definitely doesn't give you that kind of opportunity, because you need to you need to really cope up with larger conversion of putting more number of processing units to convert, really suiting to the kind of feed that cracker needs. So any feeds, essentially the lighter and the extra light would be, in my opinion, will be best for, but the availability of this kind of crude will be very, very limited. So maybe a mix of these two will give you a kind of configuration, thereby you attain a chemical flexibility to the tune of say 70% plus, which is possible. And this will really, give you the kind of, starting from C4, C2, C3 to aromatic. So the benzene, the xylene. So thereby you will be able to maximize the entire value chain. So really, it really, depends on where I am starting today and what is my plan that I am thinking, maybe the 5 to 7 years horizon that you are thinking. That is the kind of goal we should keep in mind, so that, it gives me the base slate and the, one after the addition of units one after the other, so that you ultimately attain a capacity. So this will also address the question of sustainability and optimize the entire flow sheet and the way you are going to build the infrastructure, like, the utilities. So where this will give you the kind of chemicals that we're looking at a refinery scale, at a lesser cost, with a lesser amount of the crude that we are going to process. So in an overall sense, the profitability, you can say that, I'll give you a number, say standalone refinery, which we are giving you, maybe it's a very, very old numbers, 20 to 25%, the chemical giving rise to a $9 on average margin, vis-a-vis when you turn it to 70% in that range, your margin becomes $17. So that is almost doubling the margin in terms of your per barrel. So that's a kind of beauty lies in it, but at the same time, your capex becomes double. So, but what I mean to say is, in overall sense, will reach that kind of, profitability regime by really designing and looking at crude into the lighter zone. So that would be the take that possibly all the upcoming COTC project thinkers in India will be adopting it. Thank you.
Thank you, Mr. Sur. Uh, my next question is for Dr. Maitra. Uh, Dr. Maitra, Reliance is already has gone in a big way for this petcoke gasifications. Is there any thought for integrating further with coal also in this area, or only petcoke gasification will continue?
The plan is supplement the existing gasification, petcoke gasification, with biomass gasification as well. And let me explain it slightly more. In a gasification, the cost of the gasifier is only 30%. It's large, but 30%. The remainder is the cost outside the gasification battery limit. That is cleanup, syngas cleanup, sulfur plant, shift, hydrogen plant, and so on. So essentially, we want to leverage this investment which has been made and which is already existing and operating to supplement it with biomass gasification. We are not looking at wood-based gasification because we don't want to cut down trees.
Thank you very much.